So are there any questions for Jacinta? Raise your hand so I can see you, and now I'll just have to run over to you because you're in the wrong aisle.
Because Chris needs exercise.
Are you going to put this on the CPAN?
I'm not really sure that it would be of sufficient general appeal, but if I talk to my client and they're happy for me to do so, I will.
Can you switch this to document camera before you unplug and you start setting up?
Yep.
Any more questions for Jacinta? Yep. Oh, in the middle? Not a problem.
Two related questions.
Yes.
Firstly, why didn't you look up by the start of the line rather than iterating over the types? Because it looks as though it's structured so there's a unique string at the start of each line that tells you how the rest of the line should be parsed. You don't necessarily need to know the rest of the structure.
Oh, you would so love to believe that, wouldn't you? The very first record I had a repeating token every hand-wavy number of lines, records that indicated where we were up to that still started with its own, the same code all the way down. And many of those blocks in between were conditional or optional. So you could go from this is a marker for we're starting the third kind of block to this is a marker for we're starting the 10th type of block, like that. And it was...
Right, so the data's broken.
The data was challenging, shall we say.
Right. Second...
Your related question, did you have one?
So I'll let you ask that later on. Unfortunately, we really are running tight on time. So everybody please thank Jacinta for her talk. Now there's been a bunch of people waiting patiently at the back of the room trying to find seats. So if people who are already seated, if you could sort of defrag yourselves, leave some space in the aisles for people to sit down easily, that would be awesome.
I don't have anywhere to put that.
Put it on your belt, right there. You're going to have to put it on yourself somewhere. Wait a minute. Just see if you can get it on your belt there.
It's not really a belt.
So our next talk... Okay, so our next talk is being presented by Katie Miller and Steve Dalton. Katie's a software engineer at Red Hat who used to work as a journalist and loves functional programming. And Steve I have often described as the Gold Coast tech community. They're going to be talking about doing interesting functional programming things in languages that are interesting but aren't functional. So could you please welcome Katie Miller and Steve Dalton.
Good morning. Can everyone hear me at the back okay? Yes? All good? So, yeah, I'm Katie and this is Steve, as you can probably guess, and today we're going to talk about principles of functional programming. Who learnt about functional programming in, say, uni or TAFE and hasn't really looked at it since? Yeah, a lot of the room. And who had like a really crazy professor who was really into functional programming, Haskell list, maybe had a Unix beard? Yeah, a fair bit of the room. There seems to be one on every campus. Well, what we want to try to show today is that that professor was actually trying to teach you something that's useful, something that's relevant to your everyday coding. Functional programming is often presented in a way that makes it seem highly academic and perhaps inaccessible. Our aim today is to explain a few concepts in simple terms using popular programming languages that aren't generally considered functional. There's no shortage of these terms to choose from. These are just a few of the seemingly esoteric terms you might see in discussions about functional programming. Given the time constraint today, we can't possibly cover all of them or go into any great depth, but we're going to try to shed some light on the highlighted terms and hopefully make them seem a little less intimidating. We're also going to give 4 examples of how particular FP concepts or ideas could be applied. Because we do have such a short amount of time today, we're going to go at quite a fast pace, so apologise for that in advance, and also ask that you keep your questions, comments, heckles to the end if you can. So first things first, what is functional programming? Well, it's a programming paradigm for which the fundamental operation is the application of functions to arguments. We all know functions from, say, basic maths. Let's say addition. It takes 2 arguments, 2 numbers, and returns a single result, their sum. If it's a pure function, it only operates on those 2 arguments. It doesn't open a database connection or email your mum. It's, apologies. It has no side effects, as a functional programmer would say. And if you send in the same 2 arguments to that function, it's going to give you the same result. We refer to this as referential transparency, and it's a big win. But if all you can do is apply functions to arguments, you might wonder how you get some real serious work done. Well, in functional code, main program is typically written as a function, surprise, surprise, which takes the program's input as its argument and returns the output as its result. This main function, though, is typically composed, made up of more functions, which are defined in terms of other functions and so on and so forth until you reach the language primitive. So it's quite a modular structure. So there's typically no variables in this way of operating. You just have values that are passed around. And as opposed to imperative programming, you typically don't tell the computer what to do as such. You tell it what stuff is. What is addition? What does it mean to do addition? And it calculates your final result. In order to program this way, though, you need functions that are first class. And that just means that functions are values, like the number 8 or the character A, and they can be passed to functions as arguments and returned as a result. And functions that take other functions as arguments or return them are referred to as higher order functions. So that's a very brief overview of what FP is. You may wonder, is this stuff really becoming more popular? Well, here's a list of some of the languages that people typically associate with FP and their GitHub rankings. Clearly FP isn't the dominant programming paradigm, but it's not doing too badly. There's a swag of languages supporting functional way of programming that have emerged in the past 10 years or so, and there's also been a lot of functional features that have been added to languages. According to O'Reilly, there's been a rise in the number of FP language book sales, and there's also been a lot of high-profile companies coming out and talking about their use of FP, such as Yahoo, Facebook, and Twitter.
So what are the benefits of functional programming? Well, firstly, due to something called referential transparency that Katie talked about before, we can do equational reasoning of our code. This allows us to understand the program behavior better. It's a lot like maths. That's the best way I can really describe it. And a lot of people say programming is like maths and maths is like programming, so that's the way I think of it anyway. It removes side effects and aids concurrent programming, so there's basically a lot less places where bugs can happen as well. And modularity and functional composition aids code reuse. So I'll give you a quick example here. This is not in any particular language, but we have a to-up and a trim, and we can compose those together into a function and then call that together. In Haskell, that would be a dot. I've just kind of written it that way just to be a bit more accessible to you. We believe programs are more succinct in functional programs, sometimes debatable. And finally, automatic test generation. So we have tools like Scala Check and Quick Check, which is something you might know. Those have been ported to almost every language in some way. Often a lot easier to do in functional programming though. And finally, this is, I think, one of the best reasons is something that Simon Peyton-Jones said. But yeah, it will just make you a better programmer in general. He was talking about Java programmers, but you could really replace Java with anything there. And we found, we did a study group together, and it just rewires your brain, thinks about programming in a different way. So one of the first things we're going to example is immutability. So why would you be interested in immutability? Why would you use immutable? So firstly, it protects your code from misuse. So one of the examples some people might think of if you're in the Java world is the string class. So string is immutable in Java, and a lot of people wondered why that was. But as a result, when you look back on that now, it's quite hard to do bad things with string because it's immutable, and we like that. Also, unchanged parts of structures can be shared, so it's not quite as wasteful as you might think. but he can, say, allow you to share objects within multiple threads quite easily without having to worry about all those weird side effect problems. It encourages us not to throw away potentially useful data. So the example a lot of people give is the shopping cart. You know, you put something in the shopping cart, they might take it out, and then they may not continue with that item. But the fact that item was in the shopping cart is useful data, and it might not be great that you throw that away. So, and this has really been embraced in the big data world. We don't throw anything away anymore at all. It's useful data. So here's a quick example in Python. Unfortunately, in dynamic languages, we have to do a little bit more work to actually make immutable classes. So in this example here, I have a dog, and I've protected the setter with throwing an exception, which is probably C guys and compiler programming languages. People would probably think that's horrible, but this is the way we do it. So if we create a dog object there called Billy, if we try and change the name, it will throw an exception. You can't do that. Sorry. Same in PHP, it's a little bit more boilerplate, but the same effect there. We have the setter with an exception, and you can't change the name once it's been created. And this is a slightly more useful example. In PHP, they have a datetime object, and that is actually a mutable, datetime class. That's a mutable class, and actually causes a lot of bugs, and it's a bit of a pain, apparently. So someone wrote a immutable datetime, and they've protected the setter again, you can see there, and the add methods, they've got the clone in there. So when we do an add, we actually create a copy and actually return the copy. So we don't actually change the original object.
The next concepts we're going to look at are lambdas and closures. For anyone unfamiliar with the branding on the sheets behind there, that's the lowercase Greek letter lambda. So lambda expressions are functions that don't have a name, or in other words, anonymous functions. In addition to the languages typically used for FP, you'll find them in languages including JavaScript, Perl, PHP and Ruby. They're convenient in languages with higher order functions because they enable you to plug in your function definition straight into the function or method call. A closure is a function that may access variables that are defined outside it, and it consists of both the function, which may or may not have been defined with a lambda expression, and its referencing environment, which you can think of as a table to keep tabs on its non-local variables. So a closure is actually produced at runtime when your function is evaluated and any non-local or free variables it accesses are bound to variables from the surrounding scope. And again, in addition to your typical FP languages, it has quite a bit of support in languages including JavaScript, Python, PHP. Java, unfortunately, doesn't have support currently for first-class functions at all, but you can simulate them using function objects, and lambda expressions are coming in Java 8. So I'm going to give an example to show how closures can be useful with real-world code from a Java 7 project, because it's among the ugliest, messiest languages to use for this. So it's only going to be simpler and more elegant in other languages you may use. So what we've got here is, as I said, an extract from a real-world class, although I've changed the identifiers. And here we have just 3 methods, and this is doing REST API calls, although that's not really important for this example. 3 methods, but in the original class there are actually 26 methods like this. And I say like this because if you can have a look at you see a pretty clear pattern here. In fact, there are 5 lines of code that are exactly the same in each one of these methods. The only real line that differs a lot is the one that starts with create REST client in each method. So that one's a bit different. That's what's doing the real work with the method. So this doesn't follow the dry or don't repeat yourself principle very well, as Jacinta was talking about earlier. How can we make it better? We could use function objects. So to do that, we define a single method interface, which is caller up the top there. And then we refactor and move all that duplicated code out into a method, which is doCall there. That's one of our function objects, caller. So we've got that same try-catch scaffolding that was repeated before, and now instead of that one real line of work, we're calling the single method on our interface, so restcaller.call there. And this means we can now refactor those other methods to look like this. So now we're just calling doCall, and we're using anonymous inner classes to create an instance of caller, and then just feeding in that one line of work. So I think this is better. This is definitely more maintainable if we have to change something and say how we handle exceptions. Now at least we only have to change it in one place rather than 26. However, you may have noticed that we haven't actually saved any lines of code. The methods are exactly the same length as what they were before, so it's more maintainable but just as ugly. Not so in Java 8 though. In Java 8 we get Lambda expressions. So the code at the top is pretty much the same as before, but now you can see instead of the anonymous inner class, we've got this syntax here, which is the Lambda expression. So now we can feed in our one line of work that way, and we do save lines of code. It's much more elegant. You also might notice that we've dropped the final keyword from the variables we're using there. Of course, you have to do that with anonymous inner classes. In Java 8, you don't have to declare the variables as final, but they do have to be effectively final, so you can't change them after they're instantiated if you want your code to compile.
So when people think of functional programming, they think about we don't have loops, and that's true to some extent. And I'm going to give you a few examples of how you might avoid using loops. Not there. So first of all, we use recursion and higher order functions, and Katie alluded to that a bit before. They're generally shorter and more elegant. And higher order functions, I'll give you a few examples of these. You've probably heard of them. One is map, which applies a function to every element in a list. That can also, depending on your language, will work on any other data structure, such as trees as well. We have filter, which filters a list based on a test or a predicate. And finally, we have fold, it takes a function, it kind of folds that function between the or data structure. Fold is kind of a magic function. It can be used for lots of different things, and you can actually create a lot of different functions out of fold. And finally, we have list comprehension, which is basically an alternative syntax to loops, which comes from mathematical comprehension. The final criticism on recursion that a lot of people talk about when they talk about functional programming is it can be slower and more wasteful, because you do have to maintain a stack, and if you're not careful, you can really blow up your stack and cause all sorts of problems. So if your language supports it, we recommend you use tail recursion. And tail recursion, basically, if you use tail recursion, there's a thing called tail core optimization, which allows the compiler to actually optimize your code. So if your recursive function call is at the end, it will actually compile that so as if it's an imperative language. Now, some languages, such as Java, don't actually support tail core optimization, but some of the clever people have actually got around that using something called trampolining, which some of you might have heard of. That's used in Groovy and Scala to do tail core optimization. And trampoline is just another method that you call through to get to your actual function, which does clever things. I'm going to give you an example. I'm not a Perl programmer. I hope this is correct. I think it is. Someone's checked it. This is a map or a field in Perl. So we have a list of 1 to 4, and we basically pass that, in this case, it's the ×2 function into the map with the list, and that's the list, and we get 2, 4, 6, 8. Here we have a filter. So a filter here, we've got the greater than 4 predicate, and that will return, 857. And in Perl you can pass either a regex or a block. Some of these, in all my examples, they're blocks. So this is a fold. So this is in no particular language, but if you haven't seen a fold before, I just wanted to quickly show that. So a fold, you pass a function, starting element, and then the actual list that you want to actually fold over. So you can see from the diagram there, we start with 0, take the first element, add that on, and take that off the list, and go all the way down until we get to a final result. And, a lot of people would see this as a reduce in the map reduce world. Folds are kind of a bit more than reduce, because you can do a bit more with them as left and right folds and other things you can do. So this is a fold in Perl. In Perl they use a method, keep saying method, sorry. A function reduce, you pass a block or a regex, initial value and a list. And in this case here, we pass the less than, and that results in 1, which is equivalent to the min function. Here we have string, passing the LT to do string comparison, that's equivalent to the minstro. In this example here, I'm using the init value there, the 0. And that gives 55. If you didn't pass the 0 there and you passed an empty list, I believe you get an undef. So that's why people suggest you. But a lot of the Perl examples don't have that. But I discovered that to my interest when I actually ran all these examples. And then finally, we have string concatenation, so passing the dot. function there. This is a list comprehension in Python. It's going to be in a minute, actually. That's a standard for loop, and that can be rewritten that way as a list comprehension. And that's the result.
Okay, so the final concept we're going to look at, or the final idea, is the option or maybe data structure. Now, although this is a data structure or a type rather than a functional language feature per se, it is typically found in functional languages, and it's a useful concept to know. So a maybe or option data structure wraps another type, say an integer or a string, and it specifies whether or not a value is present or absent. Some people like to think of it as a list that has either no elements or a single element. So it's useful because wherever you use this type, you're making it explicit that there's a possibility there may not be a value there. A lot of languages use null for this purpose, although even the inventor of the null reference now calls it a mistake. The problem with null is that it can be ambiguous. It's not always clear what a null return type means, as this quote demonstrates here. And it's not always obvious either whether or not there's a likelihood null will be returned from a method, from the signature. So when you use maybe or maybe or option data structure instead, it makes it explicit. It's hard to ignore the possibility. So I'm going to give an example using Google Guava's optional type, which its two possibilities are either an optional.absent or an optional.of wrapping the type. But before we get to that, let's just see how it may be ambiguous. So we've got just a standard map here. We're putting pet enclosures, we're putting in a number of an enclosure and the animal inside. You notice that one has a null value. Then we do our normal map.get on that, print out what we get. The question is, what does it mean if we get a null here? Well, we don't know, it's ambiguous. It could mean that we've fed in an enclosure number that wasn't in our map, or it could mean that, like 103, the value was null. There's no way to tell with map.get. So how can we make this more explicit using optional? Well, there's lots of ways you could model it depending on what your aim is, but here I've created a little utility method that returns an optional of optional. So that's representing the two ways we can fail. The first optional, we could fail because the key may not be in the map. The second, because the value may be null. And the way that we're able to distinguish, map does provide a method that allows you to distinguish that contains key. So if it doesn't contain the key, we return an optional.absent. Otherwise, we return an optional of containing our second optional, this time using the from nullable method, and then doing our regular map.get. From nullable will turn a null into an optional.absent, or otherwise return an optional of the value that we get back. So how do we use this? Well, back to our same example. Now, instead of doing a map.get, we're using our lookup utility method, and we're able to test for the present. So we're doing the enclosure value is present. If it's not, we know that that enclosure number wasn't in the map. We can do whatever we want to do, print an error and exit. Otherwise, we get that first level of optional, and then the or method there is actually a second kind of get, but it allows you to feed in an alternative value that you want back if it is an optional.absent. So here we're feeding in nothing. So our final line there is now either going to print enclosure contains spot or fluffy, or it contains nothing in the case of 103. It would be remiss of me to mention the option or maybe data structure without mentioning that it's often actually monadic. It's usually a monad, although the previous example wasn't. We don't have time in this talk to explain monads, but you can, for obvious reasons, but you can think of it basically as an interface with two or possibly three methods that need to be implemented. And just please don't be scared of the term if you're not familiar with it. People often like to make out that it's really intimidating. It's really not. This is just a snippet of code from a full example by a guy named Mario Fusco. The full code is on our GitHub and also on a blog that we'll link to later. So we're not looking at the actual implementation here, but this is using an option type, this time option.sum or none, same kind of idea though. And these are two methods doing the same thing. The top in imperative style and the second using this option type. And they're basically just getting a value out of a map that's expected to be a positive integer. And if it's not a positive integer, we want 0 returned. So you can see just by looking at it that this second example is much more succinct. It's actually a single line if we wrote it that way, and much more fluent. You can look at it as a bit of a pipeline. Each one of these chain method calls knows how to handle it. If the previous one returns an option.absent, it's going to be handled gracefully. There's not going to be exceptions or any blow-ups here. We're also using some of the new Java 8 syntax. In filter there, we're using the Lambda expression to send in a predicate. And also this other funny syntax above that, that's method reference syntax. So it's just a way to reference a method that's defined elsewhere, as if it were a lambda defined there. And finally, lest you think this can only be done in Java, I've got an example from Fraser Tweedale. This time the type is called maybe, and its possibilities are nothing or just whatever the value is. And if you look at the bottom, we can see an example of it being used in the case of division. We all know divide by 0 causes big problems. Not so here though, in our little pipeline there, and I should point out that the right shift operator has been overloaded here, so this isn't your regular right shift. If you look at that as a bit of a pipeline though, and you can see the results of what's printed at the end, when there is a divide by 0, it's handled gracefully. It's just passed on. So we don't get any issues here because it's made explicit. So that was a bit of a whirlwind tour of Lambda land. If we have successfully whet your appetite to learn a little bit more and see how some of these concepts might be applied to your code, what should you do now? We suggest just first of all finding out what's out there for your everyday language. There are quite a few functional languages, libraries for different languages. Seems almost every language has one, so definitely have a look into that. Joining a user group or a meetup is also a great way to learn. They're all around the country, and you can use those links there to find one. Learning a functional language. We're not here to tell you to replace whatever language it is that you code in with a functional language, but as Steve mentioned earlier, we have found that learning one does change the way that you think, and it enables you to then apply those concepts better in your everyday language, so we'd recommend that. And yeah, doing it in a study group. We learnt Haskell going through the excellent Learn You a Haskell book over about 6 months, meeting once a week. It was a great way to learn, definitely shared insight and all of that, so we'd recommend that. And again, there's a link to the GitHub of where we did that. And finally, if you're already a pretty competent functional programmer and you want to go a bit deeper, there's a Lambda Jam conference happening in Brisbane in May, the first one of its type, so another thing to get to. As I mentioned, we've got a bunch of links, like a lot of links, so if you're looking for resources, there's plenty there. Finally, does anyone have any questions?
So the AV people tell me that they're working on the annoying beeping sound. You may have been annoyed by that during that, we apologise. So are there any questions?
How does one go? Sorry.
Oh, no, it's not. That would be a good idea.
Yeah, how does one go about benchmarking functional versus non-functional versions of code? Is there some standard way of doing that, or is it really language dependent?
Yeah, okay, cool.
Do you mean in terms of efficiency or lines of code, or what sort of benchmarks? Anything?
Yeah, sorry, especially in terms of speed, because I mean, I come from a background where I've got to get everything running on supercomputers really fast and parallel, etc., etc.
Yeah, well, I've tried to find some. There's a few, what is it? There is a speed test, I can't remember the website of it now, where someone has attempted that. I think Haskell comes off looking about as good as Java, roughly, in most cases, but there's a lot of factors that... Program language shootout, that's the one, yeah. I mean, there's a lot of factors to consider there.
Between languages, I meant within
Functional
one
or
language.
imperative, yeah.
Oh, okay.
Well, yeah, you could use any tool that you currently use in your language, but do you want to see data, or you want to actually use a tool to actually compare the two? Is that what you're saying? Sorry, I'm not quite sure.
Yeah, okay, what was the question?
Just saying you're looking for a tool to benchmark between the imperative version and the functional version, the same thing.
Yeah, exactly, right. So, I mean, I've got usually an iterative version of code, which I've already written. It runs reasonably quickly. Maybe it's not as maintainable as I thought. So I'm going, okay, well, maybe if I write a functional version of this, it'll be almost as quick or better or something. But then, like, how do I know what the trade-off is?
Yeah, well, you just have to use your standard tools for any language, I guess, and do the benchmarks. It really depends. Sometimes it might actually be compiled to the exact same machine code. It just depends on how you actually write that, how you split it up. You may actually be able to split the code up differently in a different way. Once you go to a functional paradigm, you might be able to run it through MapReduce or something like that and actually totally change the way the thing works. But yeah, it really depends. That's not a very good answer to your question. So.
Okay, so we've got time for one more question. Are there any more? Great.
Just a quick question. Would you guys think the future functional programming languages, are we looking at more hybrid stuff, or do you think the purest approach of Haskell or something like it will come back?
It's a good question. I wish I knew the future. I mean, I guess the popularity of language like Scala probably indicates that maybe the hybrid approach might be what's successful, but...
I tried learning Haskell a whole bunch of times. I don't know. Lots of it, but to really get a feeling for using it just innately in my code once I started using it.
Oh, so you unplug. Oh, right. So if you know.
And I think that's much more common. I mean, there's not that much Haskell in prod and, you know, real-world type projects.
Yeah, I'd agree.
In banking a little bit.
There are some really awesome Haskell projects. Yeah.
Okay, so everyone please thank Katie and Steve. So we're going to take a few minutes.